So let's begin. Welcome, good afternoon. Today I would like to tell you about an exciting implementation of artificial intelligence. Shimadzu's newest technology called SCORE Opera implements AI-based deep learning image processing for interventional imaging. So I'm Tim Stevener. I'm the Director of Interventional X-ray for Shimadzu Medical Systems in the United States. And I started my career as an X-ray technologist at a time when new computer technology like CT and DSA was starting to get very exciting. And I became fascinated with the idea of what computers can do to help in healthcare and improve imaging. So today, we're going to talk about something even more exciting, how artificial intelligence can benefit healthcare and imaging overall. So John McCarthy is widely regarded as the father of artificial intelligence, and to paraphrase him, our objective should be to have algorithms and programs think like humans, right? Have the same experience and learn as humans do. So Shimadzu Corporation has had a long history in artificial intelligence and high technology. We're a high technology company in our background. So in the 90s, we actually used neural networking to gain better control of image contrast. And then in the 2000s, we progressed to using pattern recognition to reduce noise in the X-ray images and improve the image quality. Today, we're actually using AI assistance to be able to improve the image quality and create a filter to be able to raise image quality and lower dose. So in medical imaging, we strive to lower the dose while maintaining the image quality. Inherent in the concept of as low as reasonably achievable is that we maintain that image quality in order to achieve the lower dose. The challenge is to strike that balance between the image quality and the dose level, and that's where it becomes a little more tricky. Not unlike the balance that you would see in an opera, where the orchestra can't overwhelm the voice of the opera singer, nor can the opera singer overwhelm the melodies that come from the orchestra. So our image processing algorithm strikes that balance very nicely with SCORE Opera. So the fundamentals include motion tracking, noise reduction. It starts with these basic building blocks, and in layman's terms, we're basically stacking information to be able to reduce noise, but at the same time, we're adjusting those images to bring out the details in those images. If you look in the lower right, you'll see that in traditional image processing, recursive filtering, oftentimes you'll see a shadow in the image represented here as a double catheter. The trick with the motion tracking is to be actually correct for that motion and actually give you one image and eliminate the shadows. The second fundamental building block has to do with object enhancement or edge enhancement. In real time, we extract the linear structures out of the image, then we separate them from the noise and enhance the image while we suppress the noise. The finer the structures are, the more difficult it is to be able to discern those linear structures. And so we enhance the enhancement algorithm with a multi-frequency processing to be able to see those more complex edges. So the technology we're introducing is called SCORE Opera, and with those fundamental building blocks, we're adding an AI filter using deep learning, and I'll explain that a little further, to supplement those basic building blocks. So this is allowing us to improve device visibility even at lower doses. So deep learning, for those of you who are not familiar with deep learning, is basically feeding a computer large volumes of data so that the neural network can learn as a human would about the objects that are in that data. So what we've done over time is provide a variety of different types of images. You see them here, and that helps the AI filter learn which line structures are significant. It helps it identify the noise and improve the contrast. So first we start with a variety of different types of images. And then we take the same images and we vary in a nonlinear fashion. We change the structures in those images by changing device contrast, imaging contrast, and noise characteristics, so the algorithm can learn about all those characteristics on a single individual image. All the while it's learning what the best possible image would be and what the significant structures are to be able to pull out of that image. So the result looks like this. The image on the right-hand side, your right, is the SCORE Opera image. It is an improvement over our previous SCORE Pro Advanced image. This is our algorithm that we've used for many years. And the SCORE Opera image, you can obviously see the catheter guide wire much more clearly in that image, even in a moving image. So a little bit about the results. In the traditional rules-based image processing, it's really difficult to identify and extract low-contrast devices. Okay, so with a catheter, as you see on your left, it's very difficult to discern that with the noise in the background in the coronary image that's there. So you have low contrast areas where you don't really see the definition of detail. It doesn't stand out very well. But on the image on the right, with AI-based SCORE Opera image processing, it identifies the structures and pulls it out of the noise in the background. In another example, traditional guide wire, no contrast media, or it's actually a catheter without any contrast media put in. You can see the tubular structure just barely on the image on the left. And without the contrast in it, it's very difficult to pull it again out of the noise and the different contrasts that are in that image. So on the right-hand side, you see it much more clearly where the Trinias Opera is able to identify it and make it, enhance it. So moving devices always provide a significant challenge to any image processing algorithm, and they're much harder to enhance. So in this guide wire example, the image on the left, very difficult to see that guide wire with traditional image processing, whereas on the right-hand side, once the SCORE Opera algorithm has identified it, it actually is easier to actually see that and pull it out of the background. To add to the image processing algorithm, we've actually been able to lessen the pulse width, and by lessening the pulse width, you can lower dose and reduce, geometric blur because you have a shorter time frame to be able to capture that image. So it will, the reduced dose will give you the ability to drop down lower and see the same image quality. In testing, when we've compared our current algorithms called the SCORE Pro Advanced to the current SCORE Opera, the new SCORE Opera algorithm, we found that we're able to reduce the dose by 40% in the lab. So to supplement the AI-based image processing, you need a lot of features to be able to support it as well. So the goal is really to reduce dose across the board. So by giving the users their own control with something called dose conductor, where you can boost or lower the image or the dose as needed. Better reporting to where you can see the dose when you're done and be able to analyze what you've done in that particular exam. And then live processing or live imaging like DOSI Live, which gives you a visual reference to the amount of dose you're applying to any part of the body. The combination of all of that is what we believe will actually provide substantial dose reduction. So Shimadzu has built a new healthcare R&D center, and I think for the future, we will continue to develop and work with customers to develop more algorithms. The benefit really is to collaborate with customers, collect more data, and continue to allow the algorithm to learn and get better over time. So the fact that we have remote connectivity, obviously with computers these days, we can remotely connect with customers around the world. The ability to collect that data and greater amounts of data for the algorithm to learn gets better. And that's it. Thank you for your time today. Appreciate it.